Hello, grade 7. This is the first video that I get to record, and it's already in Unit 4 that I get to record this. So that's cool. I thought we would become less dependent on Mr. Van Donker's good and less dependent on the Khan Academy and start using our own videos. So I picked up this nice webcam over the weekend. I'm actually quite happy with how it looks so far. But let's get into it. This is 4.7 area of figures. What this is going to do is this is going to enable us to recognize, and it says this right in the sheet there, but to recognize squares and rectangles made from rectangles. So that's going to be squares and rectangles within rectangles. Once we recognize that stuff, then what we're going to be able to do is to figure out the area of these rectangles within rectangles and to use them and to add them where we need to. Now, the first example that I have here, and it's all written out, this is actually Providence Christian School. This is the school property. This little part of the diagram here is the school itself. And what we're going to do is we're going to figure out the area of that stuff. And I've already written out the formulas because we're going to jump into some other stuff in a few minutes. So what I've done was I actually printed off a photo from Google Maps. And if you look closely, hopefully it's a little out of focus, but I copied out, or I traced over the school building and around the school property and measured it out, and I used ratios to figure out the actual dimensions. Don't worry about ratios just yet for a couple more units. So what I came up with was an overall dimension here of 275 meters by 212.5 meters. And what I did was I used the formula for rectangles and squares, length times width. I did my substitutions, 275 meters times 212.5 meters, to find out that our overall area of our property, and the number could be off by a little bit, is roughly 58,437.5 meters squared. Remember, areas in meters squared, or it's in the units squared. The second thing that I did was I had the school building drawn out over here, roughly where it's located on our property. And I measured out lines again and did the ratios and found out that this is along the front of the building where the teachers park their cars. It's roughly 50 meters. And then so the other part of this building, this is the original school building here, and it's 50 meters by 25 meters. And what I did was I, again, used my formula. I plunked the numbers in to find out that that part of the school, the primary end of the school, where the kindergarten, grade 1, grade 2, and grade 3 classrooms are, is roughly 1,250 meters squared. Then what I did was I looked at the back part of the school here and found out that it was 62.5 meters by 37.5 meters. And so over here you can see I used the formula. I did my substitutions of 62.5 times 37.5 to find out that it's 2,343.75 meters squared. Again, units squared. I'm not done yet because I've found out the parts of the school building, the area of the parts, but I need to add it up together. And so what I did was I looked at the two total areas here and here, and then I added those numbers together to find out that the area of the school building is roughly 3,593.75 meters squared. That's how big a building that we have to work with. So we've actually been quite blessed with an area that large to learn in, a property as large as we have. We've been quite blessed that way. Now, let's move on to a problem that has not already been solved. And what we have here, just move my camera over a little bit, and there we go. This is an example, and it says there that it's not drawn to scale, but what hopefully you recognize is that there are two rectangles in this picture. So it's a rectangle within a rectangle. Essentially, I'm not overly concerned with the area of this shape. We can find out what it is. It's 17.5 meters times 55 meters. You can do that on your own. I'm more concerned with the area here, this sort of L-shaped section of this drawing. Now, in order to do that, I have to break the shape up into a couple of different parts. And what I'm choosing to do is I'm going to break it up like this. So now I have, we'll say I have rectangle A1 and then I have rectangle A2. So for rectangle A1, I use the same formula. Its area is length times width. And then this length here, what I do is I subtract 55 meters from 88 meters to find out that this length is 33 meters, and I'm going to multiply it by 17. I'm going off the page here, 17.5 meters. And when I do that multiplication, I get a total of 577.5 meters squared. So that's the area of A1. Okay. Now the area of A2, same thing, use the formula, length times width, and I do my numbers. So now I have an overall length here of 88 meters, but I'm not told specifically the distance from here to here. And the way I can do it to figure it out is I can take 33 meters and I can subtract 17.5 meters to get a total of 15.5 meters. Now once I've done that multiplication, I get 1,364 meters squared. Now again, like our PCS problem up here, I'm not done. I have to add these two numbers together to find out the area. So I do 577.5 meters squared plus 1,364 meters squared. And now when I do that on my calculator, 577.5 plus 1364, I get a grand total of 1,941.5 meters squared. So that's the A1 and A2. I know that I have to add A1 plus A2 to get the total area. Now the problems that you guys are going to be working on page 141 are going to be very similar in that you're going to have to break up complex shapes into simpler shapes in order to find the area of stuff. So that's it. That's the first video that we'll do. And I hope you've enjoyed it, and I hope that you rewatch it when you need to. Talk to you soon.